Hello friends, today we will learn about the photoelectric effect. It is a very important topic of modern physics. In this we will learn about we will get the little bit idea about what is the dual nature of light, and then we go for the work function, and then we will know about the what is the Hallwich and Leonard experiment about the photoelectric effect, and then we go for the stopping potential. So before starting, I will give you the brief idea about myself. My name is Utkarsh Kumar, and I did my graduation in Mechanical and Automation Engineering from Guru Gobind Singh University. After that, I worked as a design engineer in Cityo Private Limited, and after that I qualified GATE twice, and I took admission in IIT ISM Dhanbad for MTech. Currently, I am pursuing MTech in Metallurgical Engineering. So that's all. We can start. So what is the dual nature of light? Light behaves both as wave and particle. Wave and particle. This behavior of light is called dual nature of light. So we all know that in interference and diffraction, light shows its wave nature. But on the other hand, in photoelectric effect, it shows its particle nature. So dual nature of light is that light behaves both wave and particle. In which phenomena? In interference and diffraction it behaves like wave, and in photoelectric effect it behaves like particle. So now we can go for our next topic. What is work function? Work function is the minimum energy required for electron to leave the surface of metal. We all know that the metal surfaces has the free electrons. They all are conductors. So when we incident some kind of radiation on these surfaces, the electron leave the surfaces if they get the enough energy. So the energy required to leave the surfaces or leave the surface of metal is known as work function. So it is different for different elements. For sodium it is 2.75 eV. For potassium it is 2.3 eV. So now what is this EV? EV is the smallest energy. It is the smallest unit of energy. So for work function, EV is the unit. 1 EV is equals to 1.6 multiplied 10 to the power minus 19 joule. So what is this EV, or what is this 1 EV? 1 EV is nothing but the energy required by the electron when it is accelerated with 1 voltage difference, 1 volt potential difference, or 1 volt potential difference. It is all same. It is the energy required by an electron to accelerate 1 volt potential difference. So 1 eV is nothing, it is the energy required by an electron to accelerate with 1 volt potential difference. So now we can go for our next topic, Hurwitz and Leonard experiment. So what is this Hurwitz and Leonard experiment? They basically investigate the photoelectric effect. So this is the setup of their experiment. They use the glass tube with quartz window over there to incident the light. There are one electrode, there are cathode. There is one galvanometer. There is anode. When the ultraviolet radiation falls on the emitter plate, then the current passes through this whole circuit. So this is the idea about whole this experiment. When the radiation when the radiation falls on this plate, the electrons leave the surface and attract towards the anode. So it is the quartz plate. So why we use this quartz plate? Because we don't want any kind of reflection from there. So the light directly goes from there to cathode. So there is the lows of photoelectric effect. Photoelectric effect. The first law is kinetic energy is directly proportional to the frequency. Directly proportional to the frequency of the incident rays or incident radiation. Kinetic energy does not depend on the intensity of the radiation. मीन्स रेडिएशन जो है इंटेंसिटी जो है रेडिएशन की, उससे काइनेटिक एनर्जी पे कोई इफेक्ट नहीं आएगा. व्हाट इज द थर्ड वन? नो टाइम लैग बिटवीन incident radiation and emission of electron. And fourth one is that when we incident rays on this cathode or this emitter plate, the electron not directly emitted. They need some kind of frequency to emit electrons. So this frequency is called threshold frequency. Threshold frequency. If we want to emit the electrons from there, we need a minimum frequency to emit electrons, and this frequency is called threshold frequency. So these four are the laws of photoelectric effect. So there are some graphs between if frequency and kinetic energy, means when we increase the frequency, there are the point where there is no kinetic energy, or there is no electrons there. After the certain frequency, the kinetic energy gradually increases, and this minimum frequency is called threshold frequency. It is gradually increasing. As we increase the frequency, kinetic energy also increases. So now we can go for our next topic, stopping potential. So what is the minimum potential need for the anode to stop the movement of maximum kinetic energy electron? Means the electron which is having the maximum kinetic energy, तो अगर हमें उसे स्टॉप करना है तो what is the potential needed by this anode is called stopping potential. Means we want to stop this emission of electron, or to stop the maximum kinetic energy electron, known as stopping potential. Stopping potential. So we can say that stopping potential depends on kinetic energy. As we increasing kinetic energy, stopping potential also increases. So we can say that stopping potential increases as we increase the frequency, because we know that kinetic energy is directly proportional to frequency of the incident rays. But it does not depend on the intensity of the incident rays, because we know that the intensity of the radiation does not depend on the kinetic energy. So we can see that stopping potential does not depend on the intensity of radiation. So we can make the graph between the kinetic energy and intensity. If we increasing the intensity, like if there is 100 volt and then we increases to 200, 200, but there is no effect on kinetic energy. It will be constant. It only changes when we change the frequency of the incident rays. So for today's session, दिस इज ऑल. अगर आपको अच्छा लगा तो आप लाइक कर सकते हैं, कमेंट कर सकते हैं, शेयर कर सकते हैं. बाकी तब तक के लिए जय हिंद, जय भारत.